All right, we're on video 8. This video is fairly short, but there's a lot of really good, important stuff that happens in each example. So make sure you're paying really close attention as I go through. So this video is all about using the definite integral to find area, or talking about it in relation to area, which is kind of the whole point, right? So, okay. So in this first guy, we know that our function here, f of x, is the straight line 2x plus 1, and I've got it graphed off to the side. So when they write this, they want to know the area covered, the amount covered from 0 to 3 of your function. Remember, being above the x-axis has positive value and being below has negative. So let's look at what happens. So if I started my graph here, that would hit there. And if I ended at 3, that would hit here. So the question is, I want the area of that whole section. Okay, so to find the area, I can just add together various sections. I don't yet know how to do this using the antiderivative. We will talk about that soon, but for now, you're just going to find it graphically. So let's see what we have. Technically, we've got two different pieces here. We've got a triangle and we've got a rectangle. That's how I would think of this. So and you're literally just finding the area of the shapes, guys, for now. So we've got this rectangle, which is a 1 by 3. And then we've got this triangle, which is, remember, 1/2 base times height. Since it's a right triangle, I can use the base is 3. And the height is, let's see, from 1 to 7 would be a height of 6. And so I have 3 plus 9 for a total of area of 12. Okay, moving on. All right, so in this graph, I want to find the area bounded. So again, this is saying this would be the question. So the question is, what is this? Remember, this is asking for the area under the curve. Here's your curve from 0 to 2. So here's 0, here's 2. Okay, so I would think of this as a rectangle and then maybe like a quarter circle, right? So, because that's what's happening here. They're both above, so they're both positive values. This is the equation of the function. So graphically, you would have to, you'd actually have to graph that. As far as how to graph that, because that is something you're going to have to know. This is a semicircle here. The easiest way to figure out where that semicircle hits 0 is to make what's underneath 0. And so I end up with x equals 2 and negative 2. So then that would let you know. But because that normally that graph would then hit at 2 and negative 2. The problem is this graph has been shifted up 1. So that's why you see this graph up 1, and then it has that typical semicircle at 2 and negative 2. So, okay, so we want to find the area bounded underneath. All right, so we've got our rectangle and we've got our quarter circle. So our rectangle is a 1 by 2, as you can tell. So that's just 2 for that rectangular part. And then we've got a quarter of our circle. So we're going a quarter of pi r squared. And so our r here, our radius of our semicircle, was 2. Okay, so we've got 2 plus a quarter of pi times 4, which ends up being 2 plus pi. Now be careful. The graph goes all the way to negative 2, but we were only looking from 0 to 2. All right, and in this third example, which is the last one for the video, and then you're going to get to practice all sorts of shapes. In this video, we want to go from, let's see, they said the graph of f inverse, which is the derivative is given. It has 2 line segments and a semicircle, so we want the integral from negative 5 to 5 of the f inverse graph. So we want to know the area under the curve. Now remember, this part is positive, so is this part. And then the in-between portion is, again, that distance between the x-axis and the curve. But all of that is going to be negative. These are both positive, so keep that in mind. Okay, let's do it. Well, we've got 2 triangles here, and it's pretty easy to see from right now. Again, we're going to get harder. It's easy to see that these 2 triangles, they're actually the same size. They're both 3 by 2s. So technically, I have 2 of those, and the area of a triangle is 1/2 base times height. My base is 3 and my height is 2. So 3 times 2. Again, I'm taking times 2 because there are 2 and they're both positive. So then I end up with 6 for those 2 triangles. Now, the part that's under the x-axis, I'm going to go ahead and say minus because it's negative, and then I'll just include it as a positive number. So this whole area is half of a circle, and that circle is pi r squared. And the r here, let's see, the radius is 2. So pi r squared times 1/2. So I'm going to have minus 4 times 1/2 is 2 pi. Again, it's minus because it's in the negative part of the graph. It's underneath the x-axis. And then, of course, if they give you units, you could say unit squared because it's area. So in the problem set, you're going to have a bunch of different shapes. You're going to have to keep in mind that some things are below the x-axis. Sometimes you're going to have to do a little extra work to figure out how far these are. It may not be as nice. So this is just the general idea. You're going to get to practice ones that are a little more difficult.